Good morning, everyone. So, welcome. So today I'm going to talk about data science skills and development for the energy sectors. Brief introduction about myself. I train data scientists and engineers for Shell, FusionX, Intel, HP, mostly for my corporate trainings. I also run a B2B data analytics company called iStream 360. So we provide data analytics solutions and platforms for companies like Johor Corporations, MDEX is one of our clients as well. So I'm also the state advisor for smart cities and big data analytics initiatives, mainly for Johor states and previously state of Selangor. And I'm also the Microsoft Excel expert world champion. So there was a Microsoft competition last time where we were there to compete using VBAs and also macros to automate a lot of stuff for sensors network. So for quite a bit of time. So we use GPS sensors, we use motion sensors to detect the activities of koalas. So in Australia we have two major problems. I'm based in Melbourne most of the time. So in Australia we have this problem where we have too many kangaroos, but we have way too little koalas. So those are some things that we are looking into. HRDF certified expert trainer and MQA expert panelist. So I sit in MQA board, Ministry of Education, to certify data science programs for university degree, and also founding director of Magic Academy. It's a startup accelerator here. Okay, so have a show of hand. How many of you are data scientists already? Apart from yeah. So most of you are looking into a progression in your career, how to move from your current role to a more data science role, I would say, right? So that's good. So before that, as a first speaker of the day, I have the responsibility to make sure that everybody is attracted to the talk rather than talking about data science and stuff. So the first thing that we're going to talk about is the ABCD, which is the AI. So most of the stuff, when people talk about AI, actually people will be thinking about driverless cars, all sorts of fancy things, anything AI that you can think of. Basically, AI has been there for many years as well, since the very first generation of Pac-Man, Super Mario. They're some sort of AI, but they're kind of dumb in a sense. So you don't really think that they are AI, but they are actually artificial intelligence. So AI is, in the data science sense, is just that we take machine learning algorithms and then we feed them a lot of data. So machine learning algorithms depends on data to perform, right? Once you feed them a lot of data that it cannot handle, and the speed, the volume, the size, the varieties, and then we call them big data, because we are lack of better names, right? So we call them big data. So once you have big data, you feed it a lot of data to them, and you take those machine learnings to the next generations with the deep learning, with all those fancy stuff, then we are able to come up with much better applications. And those are the applications that we call the artificial intelligence applications. But before we go into that stage, this is a pretty recent article, it was a few days ago, yeah. So we will say that the right skill set for the AI revolution, no matter what, you need someone who have done maths and science, machine programming, data analysis, managed data, But most importantly is we will need data scientists. Whenever we move on to, whenever we are ready to move on to the machine learning, to the AI era, the most important role that you need is a data scientist. Not just, I'm not discounting the fact that someone who is coming from a machine learning background, who is coming from a statistics background, I'm not discounting the fact at all. It's just that those skill sets, at the end of the day, we have to package these skill sets into a study, the next generation of science, which is called data science. Eventually, every company is going to become a data company, and we're going to produce a lot of data. So there are not that many data scientists in the country yet. Okay, let's just go straight to the elephant in the room. Many people will say that I'm a data scientist, or a lot of companies, actually corporates, when they hire data scientists, they themselves don't really know how data scientists look like. Okay, so the purpose of the talk today is I'll give you a framework, a bit of context, so that you can fit them into your own situation, because everybody is handling a different part, especially in oil and gas industry. Oil and gas industry is a large industry that you can't just have somebody who look after an oil and gas project from one end to the other end. In most of the startup companies that we handle, we can, because we are focused on very niche ideas, very niche execution. But for data science type of projects in oil and gas, it's just impossible. Like most recently, we work with Xerox. I think some of you guys might have heard of Xerox. Yeah, so it's the same thing. We just look at how do they actually go to the platform, collect the data, download to the USB, and automate that sort of workflow and process. That itself is a big task already. So this is a formal session, but I would like to make it interactive. So feel free to stop me and ask me any questions if you have any. So for you as a data practitioner or someone who are actually crunching data every day, who are dealing with numberless, countless of Excel spreadsheets, so where are your opportunities, right? So there are four key roles in data science in the industry. So the first one is the data engineer. So data engineers is somebody who are engineers by trade. He or she loves databases. They are able to handle large scale of processing systems, and they have a diversified interest of skill sets. Okay, so you can be somebody who is coming from a data analyst background, or who is coming from a DBA or a data warehouse background, but eventually in the big data or AI era, you decided to move on to a data engineer role. So this guy, if you decided to become a data engineer, your role will be less on the analyst side. You don't have to worry so much about the business operations. You don't have to worry so much about how to analyze the data, but you have to focus a lot on the pre-work, meaning that how do you make sure that all the data comes in correctly at the right time, pipelines, the stability, the reliability. And if your data goes to a much larger scale, so this person is the guy that have to worry about things like Hadoop. Okay, how do you do map reduce, how do you write distributed applications and stuff. More importantly, how does your infrastructure is going to support that sort of application. You don't have to worry about Spark or any sort of in-memory processing, but you do have to know things like Hadoop and set things up. And especially scalability, right? In oil and gas, you have to worry about scalability, is the data that is coming in. So in retail or e-commerce, you don't have to worry about other stuff, but you have to worry about what if I have 10 million visitors suddenly because I run a marketing campaign. But for oil and gas, your data come in at consistent speed, but so you have to know if it reach a certain volume, how are you going to scale that? So your planning stage is actually plays a much important role. So the second person in this organization is the data analyst. So data analyst, we will call them more like a detective role. So he or she usually perform a lot of analysis, so very well versed with those things like SPSS or the analytical tools. But he or she needs to have a very strong figured out mindset, meaning that whenever is thrown a problem, they need to be very specific. They need to be very deep dive into or zoom into things like, okay, how do I figure this thing out? So they are always thrown with business questions, and also they have to understand their business operations so that they can formulate things from business questions to a data science problem very well. So this is the role of data analyst. Then next thing, you have somebody who is a statistician. So if you are focused on the role of a statistician, then you don't have to worry so much about the hardware, about the infra, about the how do you get the data, whether the data is clean or not. You don't have to worry so much. But you have to worry about the quantitative analysis, qualitative analysis. So how do you analyze different types of data? And how do you model the data? So statistician, in a way, is very similar to a modeler. So most of the companies here, they don't really specifically hire a modeler. Sometimes they always look for graduates or Bachelor of Science, Master of Science, specifically in applied mathematics, right? So they are mathematicians or they are statisticians. They are very strong in those theories and statistical methods. Now, a lot of time when somebody try to enter the field of data science, they will be thinking like, oh, do I need programming? So if I don't know how to write Python scripts, I don't really know how to use R, should I be worried, or should I need to spend another 2 to 3 years just to pick up the programming skills? Short answer is no, right? Many of my students, they are actually coming from a mathematics background. They know the models, the algorithm better than the other people and the general people. So they actually can do better than the rest because they are not bogged down by things like, oh, today they have a new TensorFlow package, today they have a new Keras release, so I should be trying out those new fancy things. A lot of the times, a lot of the algorithms and models that we use today, naive Bayesians, logistic regression, linear regression, has been there for many, many years. They are classic for the reason, right? And lastly, of course, you need to have a logical thinking mindset. Yeah, so that's what they are for. So yeah, they're just a geek, yeah, basically. So in most cases, they'll be the guy that sit down at one corner, very focused into their own problems. And then the last person is the data scientist. So they are so-called the unicorn at today's market. But sooner or later, as most of the people, or most of the professions, the previous professions, they morph into a data scientist, they're actually nothing special. They are rare at the moment because there are many people still in the process of transforming into a data scientist. So a data scientist should be able to understand all this above. So engineering, data analysis, and statistical modeling, they know how to use and apply different models. Right? In most cases, you don't have to be innovative, but you do need to know how to adjust those parameters, how to fine-tune your models, how to tell a good model and a bad model. And then you need to have a baby curiosity, right? You have to be always curious about things that happen. Okay, why things happen this way, why things don't happen that way. And lastly, he or she needs to be able to handle and manage data science project independently. I think this is a strong quality of data scientists. Because for the three professions, three key roles before this, they don't really have to do quite a lot of presentations. Yeah, they don't have to talk to stakeholders. They don't really have to understand things that well. Probably data analysts have to a certain extent, but not so much as a data scientist. Right? Data scientists, especially when they move up to the chief data scientist level, they have to sit down, they have to be involved with the management process quite a lot. So they need to understand the entire business operations quite well. And I always tell my students is that data scientists, or in most of the data science project, you only have to focus on two things. You either have to drive the sales volume up, or you have to drive the cost down. These are the two key things. So yeah, that's the main responsibility of the data scientist. Handles and manage data science project independently. So they need to look after the entire spectrum. Okay. So let's take a look at how these people are integrated with a data science process. So data science process can be split into 5 different stages. So the first part is obtain data. So gather data on your relevant data sources. Now, for oil and gas industry, we have a lot of sensors, we have a lot of machinery. So, and a lot of the data comes in linear form, right? You have to do a lot of time series analysis. You have to do a lot of go to the platform, collect the data, set up the pipelines. So those are on the platform side. But on the analytical side, you do have a lot of business operation. You need to build a lot of dashboard. So obtaining data, gathering data is the first task that we do for all the data science projects that we've done. Then the second thing that we do, of course, we clean the data. So we scrub the data, we pre-process the data to clean format that the machines understand. So in the industry, data scientists commonly will agree that 70 to 80% of our time actually we spend on scrubbing data. We actually spend our time on cleaning the data rather than focus on, or cracking your head which algorithms or which model to use. A lot of people misunderstood about this part is they didn't really spend a lot of time in cleaning the data, and then eventually the performance, the result is not so ideal, right? Because they garbage in, garbage out. So you have to spend a lot of time into understanding the data, pre-process the data. So for example, you are trying to collect the data from a particular sensors, and because of some weather reasons or because of some power failures, you lost the data for a few days or even just a few hours. So that's going to affect your analysis. So you have to understand as a data scientist, how are you going to handle that sort of problems. So after you have obtained and then you have scrubbed the data, then you need to find significant patterns and trends using statistical methods. And this is where the exploratory stage starts. So exploratory stage, usually we use very standard and common tools. You can use things like Excel, or you can use very simple Python or R scripts to help you to do that. But if you are well versed with your existing engineering tools, you are well versed with MATLAB, feel free to use that. Right? The main thing is to help you to find out those patterns and trends in your data sets that you have just collected. And once we have done that, then only we are going into the modeling stage. So modeling stage is to construct and train the models to predict and forecast. So most of the time we have insights. So a lot of people, they are talking about gathering insights, actionable insight and stuff like that. But for analysis, for reporting purpose, then we are focusing more on the high side. But modeling helps you to gain a foresight, meaning that you are able to predict the futures, right? You are going to go into predict and forecast. These are the two things that we usually do. And in modeling part, we can also do, sometimes we do unsupervised learning as well. So we do some sort of clustering to look at different types of behaviors and group data sets together, or group data points together. But most of the time, we use it for prediction and forecasting. And then the last part is the interpretations. Then only we put the results into good use. So you can take those results into your strategic plannings, into your applications. And this is what we call an awesome framework, right, in data science. So once you have the awesome framework, then we will put it into their corresponding roles. So you have obtain, you have scrub, you have explore, model, so the job of a data engineer, so the purpose of telling you this one is that eventually everybody will be quite familiar with the data science processes, but as a profession, as a job itself, even before you become a data scientist, you can start from these three roles. Or if you are a data scientist, then these are some of the things that you do need to understand as well. Because the process of any data science project is pretty much about the same, right? You obtain the data, you clean the data, you explore the data, find significant patterns, then you start to do some modeling, look at the performance of those models and algorithms, and then you interpret the results and then you tell a compelling story, right? It's always the same. But for somebody who are more into the hardware side, okay, more into the database side, you are less interested in the business side, then you can consider data engineer as part of your career, or you can focus more on the data engineering. That's an important role as well, especially for oil and gas industry. Yeah, and then for data analysts, most of the time their focus will be on explorations. Okay, and then you pass the data sets to a statistician or the modeler to do the modeling. Then only the data scientist will be in charge for the end-to-end process to do the interpretation. And in traditional industry, we do have some companies, they do have people like business analysts and stuff like that. So they work very closely with them as well. Okay. So what are your opportunity in data science if you are so if you are one of the role before? So this is the question that you have to think about it. And before that, let's quickly go into something that a new concept that a lot of people has been trying to talk about. I think Azure's, AWS, they talk about data lake. So what data lake is doing is that they want to shift the operations from ETL. So a lot of people has been doing ETL process for the traditional data warehousing, right? So extract, transform, and then load the data. So that's the reason, because we have been using a lot of structured databases like SQL mainly, yeah, whether you're using Oracle or Microsoft versions. But in the era of AI, right, let's look at this one. When you are trying to do AI, okay, this is your final destination. Your ultimate goal is to perform artificial intelligence for much more accurate predictive analytics, whether you try to use much larger data set, okay, or you're trying to optimize your operations using prescriptive analytics. Like I mentioned before, right, all these are applications. So if I have image recognition systems, or if I have speech recognition algorithms, it doesn't mean anything unless I put them into good use. For example, I put speech recognition or natural language processing into Siri, and then now Siri is an AI chatbot. It turns your smartphone even smarter. So those are applications, and if you have a lot of documents, a lot of paperwork that you need to be analyzed, then you can do text analysis as well. So these are your AI part. But before we get to that, you need to have a bit of data streaming and also operationalize, depending on how mission critical is your data arriving. So if you have a lot of ingestions, a lot of API in JSON form, then you probably need to do streaming instead of just the traditional load, transform and load. You don't even get the chance to transform the data yet. And eventually, if you want something that's very fast, then you have Apache Spark. That's for low query latency and then high concurrency. So depending on the use case. And the things before these are actually collect, store, explore. These are the standard stuff. Basically your sensors, your external data, your instruments, they come in. I don't think we get too much of the XML data nowadays, right? We mainly get CSV data. Yeah. And then you have Hadoop, you have Hive. So these are all infra stuff. So this is basically what MEM SQL come up with, is the data warehousing methodology in the AI era. So they are maturity frameworks. So you have to judge, or you have to gauge which stage that your company are at. But as the maturity goes up, your strategic value goes up as well. Yeah. So what is powering all this is what we call a data lake. Yeah. So we are no longer try to use the existing structured database so much. So we move on to a data lake architecture, which is something like this. So a lot of time when we collect the data, in the traditional way, when you design SQL tables, you have to design way in advance. Right? You don't really have the flexibility of changing the data format, changing the sequence or whatsoever. Whenever you use a data warehouse, you have to do the ETL, extract the data, transform, put them into the right design. So if any data that does not fall under the design or does not meet the design requirement, those sort of data usually will be discarded, right? Everybody should be quite familiar with that. But in data lake case, whenever we collect the data, we just dump them into the ingestion paths. So you can use AWS, you can use Azure, you can use any type of data lake, or in some of the cases, I even use MongoDB as the data lake because there are a lot of documents there. So the good things about data lake is you don't have to worry about the shape of the data, you don't have to worry about the schema, etc. You can just ingest them and you can start to blend them. All right, you can take a part of the data for your AI, for your modeling, for your training process to start to see results. You don't have to wait until the part where you actually put them into a structured database, then only you start to think about, all right, where should I write my first query? Select star from this, and then yada yada yada. And then you put into a reporting engine, and you start to customizing them. All right. In the modern days data science processes, we don't do that. We collect the data, we straight away ingest them. We do an ELT process. We extract the data, we load the data, and then only we transform. Right? After we blend the data, we get whatever we want, then only we start to transform. So after we transform, we can still put them back to the structured databases if we want to, or we can straight away publish them and put them into good use. So this is what a lot of the modern companies, Facebook, Uber, Grab, they're using similar architecture. Yeah, we don't worry so much about the transformation part anymore, but we worry about getting the results at the earliest stage so that we know what to do and how to react and respond when something happens and something is needed. Okay, so before we go into QA or before I end my presentation, there are three key takeaways that I would like to share with you is, number one, start your transformation journey now. So eventually, most of the companies, I would say 99.9% of the companies, they will become a data company. You're collecting data, you're consuming data, you're publishing data, you're putting data into good use. Not just because you can't trust your guts anymore, but it's just that the amount of data that it comes, that arrive is at the volume, as a speed that human can't process it anymore. Your existing software, your SAP software, your Excel software, they can't do it anymore. Alright, that's one thing. But as you as a person who are transforming into the next generation of data practitioner, you are coming from a data analysis or you are coming from a statistician or data engineering background, it's easier for you, you are currently in the oil and gas industry, to progress into the next level of your career rather than taking someone like us and teach us how to do oil and gas. That's very hard. I mean, for my case, because we handle a lot of different projects, so we handle different corporate projects, so we're able to go in at a very early stage to identify some of the data problems. The common issues, we have no problem tackling them. But when it comes to very specific, very niche problem that is your domain expert, that only applies to your industry, it's much easier for you to transform into your designated or your desired role at the early stage. So you should be start learning and then start to transform from today, right? So the second thing that you need to do is to build up a portfolio. So this one we talk about it many times in any sort of public talks, is that a lot of data scientists, when they do something, when they are very, I wouldn't say they close up to themselves, but they just, I would say they don't have time to publish, they don't really go out to talk to the community, they don't really set up their LinkedIn profile to share stuff, they don't really go to, actively go to Quora or any type of social media to share their opinions, their views. They don't really get their voice out there, right? So if that's the case, then people won't really notice you, and you won't really, you can't really get a healthy conversation going on. So this is something that I think every data practitioner, or if you're starting to build up your data science career, that you should do, right? We are using a lot of tools. Gone are the days that we purchase expensive and shiny tools like SAS. A lot of the companies, they are trying to use, build their in-house platform, right? For example, Python and R. Tableau is still okay. Tableau, yeah, still quite popular. Power BI, ClickView, but they are those mainstream BI tools. But a lot of the companies, they're slowly moving into open source tools as well for the community support and for the fast moving discussion as well. So start to build a portfolio, and then you get out and discuss, get more, I would say, get a healthy discussion out there with the folks out there, with the community. And then the last one is, whatever you are doing, right, after the talk and after these 2 days of the events, you will definitely feel overwhelming. If you don't feel overwhelmed, then you are not learning something, right? But then when you look at the projects, and when you go back to look at your projects, most of the oil and gas projects data sets are huge, right, humongous. Yeah, it's not, in some corporates, people will say 1 megabyte, 2 megabyte. These are big data. When I ask them, it's our corporation level, why do you consider 2 megabyte big data? They say, because I can't attach it in my email anymore. So that's, if a data set that I can't attach with my email, with my Outlook, that I will consider big because Outlook told me so. I said, okay, fine, fair enough. But when you go back to build your own projects, there are 3 things, right? Start very small. Don't think about something that's too big. So usually people reverse the sequence, that they think big, but they start big, but they think small, right? So I would rather you start small, but you think big, right? You think about the projects. It can be applied to many departments, to many different geolocations, or to many of the other colleagues that can use that together. But whenever you are doing that, start small, think big. The last thing that you have to keep in mind is how to scale fast. Yeah. So a lot of times, if you look at something that is very heavy workflow oriented, so there are a lot of processes within that particular workflow, then that's not something that's worth a try, at least in the context of data science, right? You want something that is able to show results very quickly. Yeah, I don't really like the words low-hanging fruit, because I'm pretty sure that in every industry, in the context of data science, there are fruits that they are already fallen on the floor, right? You can easily pick them out and then start to consume them. So that's about it. So I think this is my contact. So feel free to reach out to me, Facebook, LinkedIn, or drop me an email if you have any questions related to data science or your career. And do you have any Q&A? Or
yeah. Thank you. Well, I've got a few questions, but do you have any? So, but the interesting thing for the oil and gas sector, so we've got this very, sort of the word traditional, but people have been working with data for many years. Like ExxonMobil has been in Malaysia for 125 years, and they're still looking at data, very old data now, and we're bringing in this new world. But I think, because people say it's much easier to teach a petroleum engineer data science than it is to teach a data science. So I was kind of thinking, do we need data scientists? Why don't we just teach all our petroleum engineers better data skills?
Exactly, but something that I would like to highlight is that many of time when somebody work in a particular task or particular role for too long, and let's say if you take a data engineer, suddenly ask them to do modeling, they will feel just like, no, that's not really my job. But eventually somebody who are looking after the entire data science spectrum, they must be able to take the data, clean the data, model the data, and present the data. So I think that's what makes a data scientist unique and unicorn in a sense. Yeah, I mean, in every single industry, like for example, palm oil, etc., or even fast food, people have been looking at reports, people have been looking for data for many years. They're crunching numbers and stuff. But to take that into AI applications, right, to model them, that itself is something that's new. Yeah, and to use that to help them to make decisions, and I think that's the part that we are looking at now, rather than the earlier stage. Yeah. So it's more towards the
And something else I think we're very challenged with in oil and gas is this sort of hype. You know, you hear somebody come in, somebody spoke yesterday, said we've saved $5 million on fuel costs on our ships.
Yes.
But it's very hard to know what to do with this, because then you'd have somebody else who's a domain expert says, well, that's impossible, or I've been doing that anyway, or it's very hard to kind of place these, how this fits in the whole sort of success picture, I think. Is that, I guess you probably have the same challenges.
Yes, I share the same sentiments. That's why, I mean, there's some hardware or data warehouse vendors here as well, right? But a lot of time I say, before you go into enterprise grade or enterprise level of investment, so meaning that if you plan to go into Hadoop, right? If you plan to go to Hadoop, you don't really have to go straight to Cloudera, because you don't really know what Hadoop is going to bring the value to you. But you can try a cheaper alternative, which is the Hortonworks version or the original Hadoop version, to play around with it, start small, and then if once you are able to show the value, then only you start to spend millions into it. A lot of the healthcare companies that we work with, they spend, I mean, if it's still recording, they spend a lot of money with...
Turn off.
Yeah, that's all right. You can check out the success stories with IBM Watsons. Right. So I think that is a positive. Yeah, I think that's a positive response. So yeah, read out the news articles about Watsons. And very recently, Cloudera and Hortonworks, they actually announced their merger. So yeah, there's something that's worth thinking. But my point is, there are a lot of tools out there that are free, that you can use it, plug and play, but you do have to invest a bit of time, yeah, probably outside your working hours, to explore what are the opportunities they can bring, yeah, by using those tools.
Yeah. Oh, James?
I have a question. When you're talking about data scientists versus oil industry specialists who are then moving over to data science, reservoir engineers or geophysicists tend to approach the problem from a physics-based point of view. That's been done often in the past because we can analyse the amount of data that was available, but sometimes also because we don't actually have, the billion pictures of cats or whatever the equivalents are that the likes of Google will be using for all of these AI-style algorithms. How do you think we find out a middle ground that respects physics, which fills in some of the gaps with the lack of the data, but also allows us to be more data-driven?
Yeah, so I think that's what I actually meant with that, like start small and think big. So a lot of people, when they start to look around, they think from the very end pictures, like, okay, today I'm going to AI-fy the entire process. So you'll be imagining that you are going into a plant and everything is automated and stuff like that. But that is only a very small part of the picture that probably the media has portrayed for us. But when you actually go into much bigger organizations, their operations are pretty much traditional, right? So that's the thing that you have to think of. So I would suggest that we still do the same thing. They can purchase, if the company allows, and they can purchase some of the tools, but it's just that there's no such thing that you just dump the data into the tools and then you'll be automatically clean the data for you and then start to process. Apart from delivering beautiful dashboard and stuff, it's still a long way before we can get to the AI side. Right? We still rely on your domain knowledge, your domain experts, rather than so get a PhD in AI and then come in and sit down with 2 to 3 weeks and then we're able to understand the whole thing. So there are a lot of things in between, that needs to fine tune. Yeah, very good question.
Another thing I'm sort of kind of this idea that you can tell anything you want to know from data is not true. So one example is sort of people's intentions. So everybody here in the room has goals and reasons why they're here, and they're personal to everybody in the room. You couldn't work that out with data just because there's no data that people are sharing, isn't it? I often think data scientists believe they can find every answer from. I mean, you've got to know the context of what you're dealing with, I guess, to know.
Yeah, context is more important. A lot of time in larger organizations, I think it takes time to get the approvals and then move through the red tapes just to get a little bit of the data. And sometimes another common problem that we face is that the data that's given to data scientists are usually in the summarized form. Yeah, so I think that's a common issue as well.
In a summarized form?
Yeah, in the summarized aggregated data sets rather than a fine granularity of data.
Fine, yeah. Impossible to do anything with the tool.
Yeah, exactly.
There's a gentleman at the back.
Actually, not really a question, but more like a thought. I mean, your session has really helped me as a good premise for my session later on in the day. Because whatever you're talking, I mean, this is exactly how we went about doing a pilot project, which I'll be sharing later in the day. Like, we are starting small, thinking big. We are leveraging on more open source tools out there in the market rather than going for the IBM Watsons and things like that. Data, the importance of data in meeting your objectives and goals. This is something which, it's trivialized, and even the customers, they don't understand.
Yes.
And, when you ask them for data, actually in this particular field, more is better rather than less. And typically what we get is a very small subset, which is not even reflective of the problem in hand.
Yeah, definitely.
So those are the stumbling blocks actually. So I'm glad you're speaking first thing in the morning. And it makes my task easier.
Thank you. Thank you very much.
Another theme I heard this Shell head of data center excellence be talking about humility, saying you have to be aware of what you don't know, and he thinks that's very important. Is that a sort of emerging theme you see in the data science world?
So in data science projects, every time, especially the first few times when we enter a data science project, the kickoff meeting and stuff, the stakeholders usually will do something. They say, nah, these are the data science. Tell me something that I don't know. Yeah, that's the hard part. And then, so we'll start to poke the clients with things like, so what is your business questions? What are your pain points? And usually it takes a while. It's not something that can be done within 1 or 2 meetings. Usually it takes us about 3 to 4 meetings, and then we come back and then we prepare another set of questions to ask them, and then we slowly zoom down the scope. So I think something that I'm trying to tell the audience here is something very counterintuitive. Rather than try to make your clients happy at the very first few meetings, I think I just make sure that they are uncomfortable. Yeah, I always make sure that they are not comfortable. So that's where we get them thinking, right? If you want to make them comfortable, it's very easy. You just go in. We just go in and sell some BI tools, right? Look, these are the beautiful dashboard, and then this dashboard. If you are using Power BI, very good. We're going to sell you Tableau, and then if you are not using this, we're going to sell you other like ClickView or whatsoever. But the tough part is really to make them uncomfortable rather than for them to throw you like, these are the data. Tell me something that I don't know, and then you go back and think about, okay, this might be what they want. This might be what they want. Yeah, I think that's exactly the problem that we're facing.
Well, I think most people in the room are probably on the domain expert side, so they're the people on the other side of the table when the data scientist goes in, I think.
That's why we're here, right? To make you feel uncomfortable. Yeah.
Anybody like to talk about how they like a data scientist to make them feel uncomfortable? Yeah, that was fascinating. It's a whole new world, this whole culture emerging, I guess, is almost more important than the technical stuff.
It's more of, you're right, it's more of a culture change, and together with a paradigm shift as well. Yeah.
Oh, anyone? That's a wonderful outline to this whole new world, but thank you very much.
Thank you very much. Thank you.